like to keep track on your notes. We are starting Unit 3 today, okay? And so this first part talks about parallel lines, which hopefully you remember from Algebra 1. Okay, we've got parallel lines do not what? They don't touch. Good. They don't intersect. Okay? So we've got parallel lines that don't intersect. So if I look, hopefully you guys can see this. You can just write them on paper. It's fine. Okay, so I'm going to have parallel lines. They don't touch. Let's say that this is AB and this is FG. Okay? To write it as a symbol, okay, you would say line AB. And remember from the first unit, when we're talking about a line, it's got the two arrows on top. Line AB is parallel to line FG. So we're lazy in math. So instead of writing everything I just said, okay, this is how we would write it. Line AB is parallel to line FG. This is the symbolic way of writing it, okay? Okay, that's also going to be similar to the way we write it if two planes are parallel. Now think about planes. Planes continue also by its width and its length. But if we have two planes that are parallel, they also will not meet, okay? They will not intersect. So I think you have line J and K on your notes. Is that correct? I think it's J and K. The way we would write it would be plane J is parallel to plane K. We don't have a special symbol for the word plane. Okay? So this is how you would write it. So these lines right here mean parallel. So if you see those on a quiz or a test, okay, that's parallel. Sometimes they're just represented straight, not diagonal. So you might just see them straight also, okay? But that means parallel. Okay, the next one is skewed lines. And I'm going to use the picture because I'm horrible at drawing 3D sometimes. Okay. All right. So I'm going to be looking at skewed lines. So skewed lines, they also do not intersect. Okay. But they're going to be non-coplanar. So if you remember, coplanar meant on the same plane. So if they're non-coplanar, that means they're not on the same plane. So if I'm looking at a three-dimensional shape, I can see that each face is its own plane. So for example, the front plane, we could say like PQU, plane PQU. That plane is parallel to the back side, which would be plane SRV, right? So the front and the back, those would be parallel. But if I'm talking about a skew line, they're actually not parallel, but because they exist in a different plane, they also will never touch. Okay? So for example, we could take TP and UV, and those are skewed lines. Okay? Because one of them, the plane is over here, think three-dimensional. The other one, it's kind of going backwards, right? So they'll never touch because they exist on a different plane. It's all about that three-dimensional kind of thing, okay? Okay, so we can do some more examples. I'll post the key of this so you can see more examples. But these are just three definitions, okay? It's really the second page that's going to take me longer, so I'm going to start the second page, okay? So here's another definition. This is a new word for us. So transversal is a line that intersects two or more lines. Okay? Transversal. So if you look in the picture, we have line L right here. And we have line M. This transversal right here intersects both lines. So this T, line T, is a transversal because it's intersecting more than one line. Okay? Now, when there's a transversal with parallel lines, it's going to start forming some angle relationships. And we have learned some angle relationships, but now we're going to learn a lot more today. Okay? So I'm actually going to go back to the whiteboard so I can show you a little better. So let's say I have parallel lines. Okay? And then I have a transversal going through it. Okay, and we'll just call this line A, B, and we'll say T for transversal. Okay? Now, if I ignore one of the lines, if I just say I have one line and it intersects, it actually has relationships we've already learned about. For example, this angle and this angle. So if I take my paper and I actually ignore this one for now, okay, what does that look like from your test? Those two angles, what relationship do they have? Anybody? Angle 1 and angle 2. What relationship are those? This was from last unit. If I add them together, what are they creating? Do they create a line? Come on, guys. Yes? Okay. If I add two angles that add up to a line, they really add up to how many degrees? 180. Does anyone remember the name for these angles then? They're supplementary. Yes? And then there can be another name because they have an adjacent. So what is it if they're adjacent and supplementary? No, you didn't forget already. Starts with an L. Linear pairs. Good. Okay, this is something we already learned. Linear pairs. Well, if I start hiding stuff, I actually have linear pairs in more places than you think. I've got one here. I've got one here. And I've got one here. So I've got lots of linear pairs in this figure. Okay? Okay, now who remembers what the ones across from each other are called? So if I'm ignoring this one for now, we'll call this 4 and this one 3. So 2 and 4, what do those look like from your test? Vertical angles, good. And remember, vertical angles are equal. So we know that 2 and 4 are going to be equal because they're vertical, which also means 1 and 3 would be equal because they're vertical angles. Okay? That's going to be the same down here. Where did I end? 4, 5, 6, 7, 8. 5 and 7 would be vertical angles. 6 and 8 would be vertical angles. 5 and 6 would be linear. 7 and 8 would be linear pairs. Okay, these are ones we've already learned about. Now we're learning, though, together? What if I have two sets, right? So now I have sets going on. I've got all these 4 angles that deal with A, and then I have 4 more angles that deal with B. So I'm adding some extra layers because of parallel lines. So let's do these ones green. And we'll leave these ones purple. So the first relationship we're going to bring up is if I look at the green angles, those are all the angles associated with line A. If I take angle 1, do you agree that that is the top right angle of those 4? Like if I was breaking those up into 4, its position is up top on the right. Out of all the green ones? Yes. Okay. If I had to match its position to the purple ones, which number matches the purple? So right here we have the top right is number 1. Out of the purple, which one's the top right? 5. So angle 1 and angle 5 have the same position. Agreed? Those are called corresponding angles. Okay? Corresponding angles have the same position. Okay? So we can do more than one here. What if we do angle 2? So angle 2 is the top left out of the green ones. Which one's the top left out of the purple ones? I'm saying angle 2 is the top left out of the green ones. Out of the purple ones, which one has the same position? 6. So 2 and 6 are also corresponding angles. Okay. What about 3? Good. 3 and 7. 3 is the bottom left. 7 is the bottom left. And the last one, 4 and 8. Good. Okay. Corresponding angles are equal. You might want to write that down somewhere. Corresponding angles are equal. So that means 2, its measurement is going to be the same as 6. Angles 3 will have the same measurement as 7. 4 will have the same as 8, and 1 will have the same as 5. Corresponding angles have equal measurements. Are there any questions of how to find the corresponding angle? It's all about the same position. Okay, I'm going to change colors for the next diagram, so I want to make sure before I erase it. Okay. Okay, the next relationship, we're still going to have 2 parallel lines with a transversal. Okay. And in this case, the way I want to color coordinate this one is I want all my interior angles to be the same color. So the ones that are in between the 2 parallel lines. Okay? This is how I want you to visualize it. All the green numbers, do you agree that those are in between the 2 parallel lines? So if I look at my parallel lines, inside of them are those green numbers. What's another word for inside? I think I've already said it once. Interior. So these green ones are interior angles. If those are interior, what do you think the purple are? Good. Exterior. This is important because it's going to help us. Okay, the next definition on your notes page says alternate interior angles. I want to find pairs. Okay, all these relationships come in pairs. I want to find pairs where the numbers are interior, but they're alternate from each other, meaning they're across from each other. So remember, adjacent means next to. Alternate means they're going to be on the opposite side of the transversal, but they're going to be across from each other. So for example, 4 and 6. 4 and 6 are on opposite sides of the transversal. This 4 is on this side, this one's on this side of the transversal. They're across from each other. Angle 4 and angle 6 are alternate interior angles. Okay? 4 and 6 are alternate interior angles. What's the other pair of alternate interior? There's only one other pair. They have to be interior angles and across from each other. Anybody? Are we awake? Do we need to stretch a minute? 4 and 6 are across from each other and they're both interior angles. What's the other pair that are across from each other? I know you know it. Come on. I know at least one of you know it. Thank you. 3 and 5. 3 and 5 are across from each other, but they're interior also. So they're alternate interior angles. Okay. Alternate interior angles are also equal to each other. Their measurements are the same. So 4, whatever the measurement of 4 would be, 6 would be the same. Whatever the measurement of 3 would be, 5 would be the same. Alternate interior angles have the same measurement. You're going to want to write that down for your homework. Okay, let's go to the exterior. The exterior are my purple. If I'm talking about alternate exterior angles, okay, alternate exterior angles, I know I'm talking about 1, 2, 7, and 8. Those are exterior. What do you think alternate means again? Across, diagonal. So give me a pair that you think are alternate exterior. What is it? 1 and 7. Perfect. Angle 1 and angle 7 are alternate exterior angles, which means the other set is 2 and 8. Those are alternate exterior angles. Those two also equal each other. So angle 1 equals 7, angle 2 equals 8. Is All right, there's one more relationship before we practice one. And it's actually got two names depending on what book or example you talk about. Okay. I like same side interior angles because in the name it tells you what it is. If I have interior angles, these are on the same side of the transversal. So 4 and 5, angle 4 and angle 5 are on the same side of the transversal and they're interior. Those are supplementary. They don't equal each other. Okay, they're supplementary. They add up to 180 degrees. The other pair is 3 and 6. So angle 3 and angle 6 are also supplementary. And we either call these same side interior angles, or on your notes you'll also see consecutive angles. Consecutive angles and linear pairs are your two relationships that are supplementary. The other relationships equal each other. Okay? So let's try an example. Okay, if I'm looking at this figure, I want to match the relationships. So if I'm looking at 1 and 8, which one of the relationships were those? Alternate exterior, perfect. What about 2 and 3? You might have to turn your head a tad, right? Because it's kind of sideways. 2 and 3, what kind of relationship? Are they interior angles or exterior? Interior. Are they on alternate or same side? So they're same side interior, okay? Or consecutive. What about 5 and 7? Are they both interior or both exterior? No, so the only one that deals with both corresponding. And are they truly in the same position? Is 5 is the, if I turn sideways, right? It's the top left of that line P. What's the top left of line Q? 7. So they are corresponding. Be careful because they sometimes try to trick you with those, okay? What about 2 and 7? Two and 7, guys. Are they interior or exterior? Interior. Are they same side or alternate? Alternate. So D would be alternate interior angles. Okay, 1 and 3. Are they interior, exterior, or both? Both. So do they follow corresponding rules? Yes. So 1 and 3 are corresponding angles. They have the same position. And then the last one, 6 and 7. Interior, exterior, or both? For 6 and 7. Interior, same side or alternate? Same side, good. 6 and 7 are same side interior angles.